Okay, that concrete structure there is where the penstock actually comes into the building. What a penstock is just a big tunnel that carries the water down when we're generating or back up when we're pumping. We have the two reservoirs, the lower reservoir, which you'll take a picture of, and the upper reservoir, which you can't see because it's on the other side of the mountain. But this tunnel or penstock comes all the way through the mountain and actually comes in right here. And it's just the one pipe, but it comes into the plant and it branches off into two for A unit and B unit. So that's what that structure is. And what kind of building is this? People come here all the time. The hydro plants, it's like a battery. It has the potential energy. Right now we aren't generating, and if we were, you would hear this loud noise out there. So right now it's like a battery. It's being stored, the potential energy. And as soon as they call for us, and what I mean by a potential energy is like a flashlight. You know, it's not on, you turn it on, and then all of a sudden you have the energy from the flashlight. So when we start generating, we start making electricity. So that's what I mean by like a battery. And here at Cabin Creek, we have three modes of operation. We can generate, and that is when actually the water from the upper reservoir is going through the turbine and going down to the lower reservoir. Here, on these dials right here, this will tell us exactly what to do. These are permissives. This will tell us to open the spherical valve. The spherical valve is a huge valve downstairs. Right now it's closed. And when we call for it to open, it will allow the water to either go down or back up. So these dials and everything will tell us exactly what to do. To open the spherical valve, when the field flashes, we'll raise the voltage. And what the voltage is we have the outside voltage that's running through the transmission lines. We have to match our machine voltage, which is our machines out there, to the outside voltage. Once that's matched, we'll get this rotating at 360 RPMs and close it in. We'll close it in by closing in this breaker. Once this breaker closes in, we have 230 kV, and that's what goes through the line. We also, on this side of it, is where we pump, and this is exactly the same thing. These are all permissives that tell us that we have permission to start. If something's not lit, that means we got to find out what's wrong. And this will tell us what to do. Close in the starting motor breaker, raise the speed, the field flashes, the same thing in here. Then the third thing is synchronous condition, when we're actually not even rotating in water. Here at Xcel Energy, we have a plan. It's all written in the book. It's our emergency action plan. That if the dam would break, we have a list of people we'd have to call first. The first people we would call would be the Georgetown Sheriff, and I'm sure they would do a reverse 911. We're also trying to get a siren system going down there. That hopefully will be in the near future. But if the dam would break, it would be, I think, let's say 15 minutes before all the water in the lower reservoir would hit Georgetown. And it would be a disaster. It won't happen. I mean, never say never, but we have to do dam inspections so often on there, and we have agencies, FERC, NERC, all these agencies who are always coming and checking our dams. So they're very steady, which will turn it, which will turn the turbine, which will turn the generator rotor. And how I always remember that rotor round rotates. The rotor has coils in it, and the stator has a copper. The copper is a conductor, and that is what makes the magnetism. Magnetism makes electricity. When we're generating, the water will come down through the power tunnel into the generating plant right here on out to the lower reservoir. Oh, here's something. than water normally is. But because we had been generating, there's the water level now. I'll take him around, show you the reservoir.
The generator's on that end with the screens, and it's got belts that stick out the front that run what's called the exciter, which is the little, looks like a little generator, basically. And then what's under this shield is the water wheels. Telling us what our penstock pressure is. So we got 300 PSI water. Just like an electric motor in your vacuum cleaner. But that outer ring of red, those are pole pieces. Each one of those is a copper coil. And the exciter excites the field and the generator. And so those magnetic fields, that's what gives you your little generator unit on the back there. So there was no house power. Right now we have house power coming from the grid, which is coming from coal plants down in the city, or Cabin Creek if it's running. Back in the day, they didn't have anything coming here, so this was the main supplier. So they would use that little generator to get the little exciters going, and then they could get, that'll excite the big generator, and then they could get the generators running and start feeding out. So we run off whatever flow we have down the river. And Cabin Creek's a peaking plant. So whenever demand is high, we turn on Cabin Creek. This one runs 24/7. Well, our black start at Cabin Creek allows us to start ourselves up if the grid has collapsed. If there's no power on the grid. A few years ago on the East Coast, they had a blackout that blacked out most of the East Coast. If there was some sort of a blackout that came here, we could start ourselves up internally at Cabin Creek and start rebooting the grid and start getting the other plants online.